So welcome to chapter 3. So chapter 3 are going to be looking at descriptive statistics using numerical measures. So we've seen descriptive statistics using graphical techniques like a frequency distribution table, cross tabulations, and stem and leaf displays. But now you're going to look at descriptive statistics using numerical measures, and we are starting off with measures of location. So the first measure we'll look at is mean. So we are all familiar with the mean, so I'm not going to spend a lot of time here. Let me just increase the font sizes. So you're all familiar with a mean. Mean is simply going to be the sum of it is simply going to be the sum of your values. So it is simply the sum of your values from I is equal to 1 to I is equal to n. So it's the summation of if you have I values. I think I needed to insert a fraction. So it's going to be that over your n. N is the number of elements that you have. So if I just make some data, then you can have let's say these are our values. So we have some i's here. So we could maybe create some random data. Run between, let's have some random data between 1 and 20, say. Let me just zoom in a bit. So let's say these are our i's. Let me just copy over the formula so that you have 20 values. Let me just fix these values. Remember, it keeps on generating new random values unless I fix the values. So this is our data, yeah. So if you wanted to get the mean, it's really easy. So let's just have a new cell here which says mean. So we say this is simply going to be, it's going to be the sum of all the values, right? The sum of all these values divided by the number of values, right? Divided by the number of values, so you get 10.4. Alternatively, for Excel, you could have the average function. You could do this in one step. You have the average, and then you just select all these values here. So it gives you the same value, right? So it's the formula here is actually correct, right? Mod is simply the value which appears. The value which appears most, yeah. Appears most. So by the way, I have to qualify this. So we are starting off with ungrouped data. ungrouped and unweighted. When you have grouped or weighted data, the formula are going to change a bit. So let's see, do we have a mode here which value appears more than once, several times? So we have these over here. If you look at this data, this data set here, you can see that this value is the mode 2890. Yeah, so the mode is simply the value which appears most. Do we have one for this data? Let's see. So Excel has a mode function. Let's see the mode for this data which I just generated. It says 1 is the mode. Yeah, so there's actually 1 and 1 there. Yeah, 1 appearing twice, but it has more than one mode, I think. 1 and 1, so it gives it a lower value because I think 12 is also appearing. So we can actually, to find it more easily, we can sort this data. So to sort data, you go to the sort toolbar. So let's sort. So it's asking me if I want to expand the selection. Well, actually 1 is the mode, it appears 3 times. Yeah, so it's a lot easier to find. Yeah, so we could. So that is the mode, right? So what else is it do we have to look at? So the other thing that we could look at is the median. So the median is going to be the middle value. To get the middle value, again, we actually have to sort the data. Yeah, we have to sort the data in order to get the middle value. So to compute the median, if you want to compute the median, you basically have to get your n over 2, the index of the median. The index is the position, right, of the median. Is going to be n is going to be n over 2. So this is going to be, if you have an even number, an even numbered n, then the median is going to be, the index of the median is going to be, if you have an even numbered n, then n over 2 is going to give you a value. Yeah, then n over 2 is going to give you a whole number. Let's just have a look here. For instance, we have in this case we have 1 2 3 4 5 6 7 8 9 10 11 12. So we have 12 values. So n over 2 is actually going to give us 6. Yeah, it's going to give us an even number. When that happens, then the median is actually going to be the mean. If you have an even numbered n, then median is actually the mean, the mean of whatever number is at the index n over 2 and the index n over 2 plus 1. What do I mean? It's because in this case the median, if you do an n over 2, so we are going to get the 6th index. So this is 1 2 3 4 5 6. Yeah, so but this is not really, because we have 6 other values, so the middle is actually here in between. Yeah, so the middle is actually in here. So the actual median is going to be the mean of 2890 and 2920. So if you want to get the actual median, is going to be the mean of 2890 and 2920, and I divide this by 2 and get 2905. I'm assuming this data is already sorted. I think that you actually have to sort the data to find out the middle value. Yeah, 2905. Let's just have a look here. Let's try to get the median of this data that we had before. So this was mean again. This is the mean again. This is the mod. This is the median. So we're getting the median of A2 to A21. Gives us 11.5. So this data, let's see what is at the 10th index, because we have 20, n is 20, so n over 2 is 10, which is 8. So actually getting the mean of 8 and 11. Is that so? So we have 10, then we have 8 and 11. Is that right? Oh, sorry, because the values start from 2, so the 10th index is actually 11. Yeah, so so we can check this, because mean of 11 and 12, so you can see equals, sorry, function is average. So you can see we actually get the same value. Maybe let me just get rid of this. This was the computed with the average function, average A2, A21. So brings us the same value, right? So similarly, you can compute the percentiles. So if you want to get the 10th percentile, for instance, or let me just more generally, if you want to get the nth percentile, the nth percentile is going to be so the index of the nth percentile is going to be n over 100 times n, where the bigger n is the number of values. So for instance, for the 5th percentile, we're going to get 5. The index is going to be 5 over 100. And similarly, if, like we did for the median, if this is an even numbered, if this is an even numbered, if it's an even numbered range, you're likely to get, if you get a whole number, then you have to get the mean of that index and the next value. But if it's you know, if it's an odd number, then you simply get the next value. Let me just show you what I mean. So let's look at our data here. Look at our data. We have 20 values. So the percentile, let's get the 5th. 5 over 100 by 20 is what? 5% of 20. Maybe let's get the 10th percentile. Yeah, so let's get the 10th percentile. So the 10th percentile should be 10 over 100. So it should be index, should give us an index, the second index, equals percentile percentile. So we want from A2 to A21, and we want the 10th percentile. And we want the 10th percentile. Okay, that doesn't seem to work. You have the arrays A2 to A. So I've seen this doesn't always work as expected, and maybe it needs us to, provide it like in this form. Okay, so it seems that's what I had to do. You provide the percentiles in a fractional form. So let me use the basic percentile function. So we have A2 to A21. So the 10th percentile is going to be 0.1. That works now, yeah. So we are getting a percentile. But let me just see what happens when I do a 2 here. So you can see that the value changes to 0.9 to 1.9 because these are even numbered values. So if you get a whole number, in this case the index that I get for the percentile is actually going to be the second index, which is 2. So what I actually do is to get the mean of 2 and 1. Should be giving me something rather of 2 and 3, which is the mean here, 1 and 2. 1 and 2 should be 1.5. Still not what I expect. So yeah, so sometimes you can get unexpected values. Let me just try and figure out if there's a anyway, I can just check this too, because the 50th percentile, so let me just check if these things are working correctly. The 50th percentile should be the mean. So it's going to be the percentile, the range is A2 to A21.5. It should be the median, so it gives me the correct median, right? But then the 10th percentile, 0.1. So in our case that should be index, because we only have 20, so that should be the second index. So I expect this to be 1.5 given this, because it should be 2, this is the second, and that, yeah, the mean of this and that. So I'm not sure how it's actually doing it. They are using a different formula apparently. So anyway, let's do quartiles. Maybe the other thing I wanted to demonstrate, if you have another value here, say 21. If you have 21 and then now you want to do the percentile, so 10th percentile for this range is going to be percentile. It's going to be percentile A2 to A22, and I want to get the 10th percentile. Is simply a 2. And reason for that now, because I have 21. If you calculate 21 divided by 10, you get a 2.1. So if you have a fractional value, then you go to the next value. So the 10th percentile is actually going to be the number in the third index. Yeah. Maybe let me just make this less confusing. Let me insert the index. The index is the position, right? So that's the first position, obviously. So let me just fill this in. So that's so this is the 21st. So this is actually the third value, right? because we had a 2.1. So so you can also do quartiles. So there's a quartile function. So the first quartile is actually the value which is at the 25th percentile. So let's see the quartiles. Let me just maybe get rid of this for now, or let me just leave it there. But let's look at the quartile. So the first quartile, Q1, we refer to this as Q1. Q1 is actually going to be the there's a quartile function in Excel. So the range is A2 to A21, and the we want the first quartile, right? It is 5.75, but if you look at the first quartile is actually the 25th percentile, because it's the value 0.25 of the way from the starting index to the last index. So it is also the same as getting, you know, the 25th percentile. If you get the percentile of A2 to A21, then you want to get 0.25. We get the same value, right? So the same thing applies if you're doing it by hand. You're going to get 25 over 100 times n to get the index. And if you have an even numbered index, you have to get the mean of that index and the next index. If you have an odd numbered index, then you have to run, rather if you have an odd numbered n, you're going to get a mixed fraction as your index, and then you're going to have to round up. Q2 is going to simply be, so you get the quartile function, then you have the A2 to A21, then second quartile. So let me just copy this over so that I don't waste so much time writing the formulae. What did I just do? So this is a quartile. A2 to A21, 2. Then this is a quartile. I should just copy over this formula. A2 to A21, 3. Then this is A2 to A21. Well, a fourth quartile should be the last value, because we're going all the way to A21. So this is the last value, right? So that's just a confirmatory test. So this is Q3, this is Q4. Then we say this is second quartile is actually the median. You can how come ours is giving us a different value? Am I using the same range? The second quartile should be the median. So let me just be sure I'm doing this correctly. Q2, second quartile. This is the median. So that is A2 to A21. Okay, so this should be A2. Oh, sorry. Because we created a new column, so that should be, we should be using B. Sorry about that. Because we shifted to B21. So I was actually giving you wrong values, B to B21. So it's coming down to, you see, Q2 is actually the median, right? That is B to B21. So we shifted over columns because I created an index column. Then this is a percentile B. So our percentiles are fine. So you have the median, which should be your second quartile. So you can see that the median and the second quartile are the same. It is also the 50th percentile, right? So that is all you have about quartiles. So this ends this first part of chapter 3.